So this is like the third lesson kind of continued. So I'll call it 3.3. I don't really know what you want to call it, but this is the third topic that we've been lecturing about in this chapter. Actually, I think I wrote it this way, didn't I? I wrote vertex form on the last time I did it. I think we wrote it in this order. Just trying to be consistent. Is that correct? Okay. So we said to go from vertex form to standard form, we expanded. To go from standard form to intercept form, we factor. To go from intercept form to standard form, we FOIL. It's time now we indicate what we need to do to go from standard form to vertex form. I'm going to write the letters CTS in that location. CTS is an abbreviation that stands for completing the square. That's a bit of a mouthful, and we use it enough that I'm just going to abbreviate that as CTS. Everybody okay there? Okay. So the goal here is going to be to take something in standard form and get it into vertex form. So I want something that looks like ax squared plus bx plus c, and I want it to then look like, when I'm done, a times x minus h squared plus k. Right? So that's something in standard form. I want to end with it in vertex form. So let's say that we have this standard form equation. On the side, I'm going to kind of sketch out some notes about what we're going to do to get it, or for this CTS process, as we kind of do this as an example. Okay with that plan? Now I want to warn you guys right now, this completing the square process is a little bit difficult. Okay? It's a very good possibility that we're going to run into dealing with some fractions here. No, it's okay. They're just numbers. They've never done anything to you. You can't badmouth fractions like that in this country. Okay. So we'll try to do a better job this year. Okay? All right. Okay. So the plan here, the first thing we want to do is make the leading coefficient equal to 1. When I say leading coefficient, I'm really just talking about the value of A. Make. M-A-K-E, make. Mike L.C. is a new student in class. He's number 1, though. Yeah, it says right there, Mike L.C. equals 1. So in our situation, what is the leading coefficient here?
1.
It's 1. So we're done with step 1. There's nothing to do for us in this particular example. The next step that we're going to do is we're going to move the C coefficient to the other side. Okay with that? So far, that's pretty easy, right? I've oversold this as being difficult. the next step is we're going to add b over 2 squared to both sides. So in our case, what is the value for b? This is b, right? So just for the sake of the notes, I'm going to write b over 2 as literally 8 over 2. I realize that reduces to 4. We're not going to leave it that way for the whole time. But if you look back at your notes, if it's just 4 squared, you're going to ask yourself, where in the heck 4 squared came from? So I'm going to write this as literally 8 over 2, so when you look back at it, it's a little bit easier to tell what I'm doing. Yes, Sierra. But if you look at your notes and you're just like, why am I adding 16 to both sides? If you see 8 over 2 squared, it's like, oh yeah, that's b over 2 squared. That's what I'm doing there. I don't know. It feels like it would be, I would be confused. You can do whatever you want, though, Sierra. They're your notes, so. Yeah. So remember when we spoke the other day, I mentioned this little expansion formula is going to become important for us. So we're going to use it a little bit later. This is when we're going to use it. It's actually the key idea behind this completing the square process. That's how we're going to, if I can scroll back up here for a second. That's how we're going to get this part of the vertex form equation, is we're going to use that little expanding formula. So what my goal was going to be is I was going to take this part of my equation and pretend like it's that part of my equation. And then I figured out what this b squared part has to be, and I added it to both sides, which is what step 3 is doing. So I can now factor this because I know it's in this special form. I know it's in that special form because I made it be in that special form. So just as a heads up here on the left-hand side, I did 8 over 2 is 4, and then 4 squared is 16. So, how does x squared plus 8x plus 8 over 2 squared factor? If I look at this, in fact, I have whatever a squared. I just take the a part of it, and that's my a. And then for the b squared, I take the non-squared part of it, and that's my b. So for us, our a is just the x, and our b is the 8 over 2. I'm going to get rid of it in just a moment. The reason I'm doing this, writing it still as 8 over 2, is so we can see it, but in the future, when we do another example where like it doesn't reduce and you're stuck with a fraction, so it's easy for us to see how I'm getting to the factored form when I have a fraction there, okay? So negative 2 plus 16 is 14. 8 over 2 reduces down to 4. I finally went ahead and did it. And now all I need to do, my last step then, is to get the y by itself. What are we on? Step 5. So I'll do that by just subtracting 14 from both sides. So there's my vertex form equation. Is everybody okay there? So if I compare this vertex form equation with the equation that we started with, if I looked at the graphs of them, what would I expect to see? They should be the same, right? So I can check to see if I've done this process correctly by graphing these two functions on my calculator and seeing if I get the same graph. That's good to know, right? Always interested in a way to check our answers because, well, I know I'm not right every single time. How do you know when you're not right? That's an important question, right? Always we're interested in, like a certificate, like how do we know that this is correct? What was that? 8x squared plus 2. And what I'm going to do is I'm going to take this first equation, or this 8x squared, x squared plus 8x plus 2, and I'm going to just scroll my cursor over to this other side of the y equals. If I press enter, there's a couple of different line options here. I'm going to graph this one with a thick line so it's easy for us to see the difference between the two as they're being graphed. So I'll do my zoom standard. There's the first equation. There's the second equation. I can see they are identical, right? So I'm quite convinced that I've done that correctly. Let's do another example of this. This time the numbers won't be necessarily quite so nice. So let's say we have y equals 2x squared plus 10x minus 4. Yes? Of course. Remember the first step was to make the leading coefficient 1. My leading coefficient is currently 2. What am I going to have to do to turn that leading coefficient into a 1? Marshall? I'm going to divide both sides by 2. And because division is distributive, I know that's the same thing as dividing everything by 2. That's going to give me this. So far, so good? Good. Next, I'm going to add c to both sides. So that's just adding that constant term to both sides. We okay there? Okay. Now that we've added the c to both sides, what we're going to do is add b squared or I'm sorry, b over 2 squared to both sides. So the b that I'm referencing is this 5 coefficient. So I'm going to add 5 over 2 squared to both sides. So far, so good. Now we're going to factor this right-hand side. So we're going to have something that looks like this. So the way we figure this out, this part is going to be what comes first. God bless you. And this part is going to be what comes second. Is everybody okay with that? So you can see again why I've left that fraction as the fraction. I haven't tried to square it. I haven't tried to turn it into a decimal. Just going to leave it like it's a fraction because it's going to tell me exactly how I have to do the factoring. Kate, you look concerned. Can I ask you, or you have a question? Are you sure? That's okay. It's okay if you do. Okay. That's how I'm doing the factoring every time when I get to that factoring step, when I'm doing this completing the square process. So it doesn't look like I'm doing the factoring correctly, right? It's okay because trust me, I am. The reason I don't have to think about it at all and why I'm avoiding all of the normal factoring stuff we had talked about is because I know that my polynomial looks like this. Because that's what the 3 steps beforehand have guaranteed, that I've gotten to that kind of a polynomial. So I can shortcut straight to my factored form that looks like this. Okay? So that's what's going on here. So if you do the first 3 steps correctly, that factoring is going to work, even though it seems like a funny factoring that doesn't seem like it works. I promise you it does. Okay? All right. So now I'm just going to start cleaning up the stuff on the left-hand side here. So I'll start by squaring 5 over 2. To square a fraction, I just square the numerator, and I square the denominator. And now I'm going to want to add 2 and 25 over 4. To add those two together, what do I need to have? A common denominator. What would the common denominator be for this? It would be 4. Everybody agree with that? So I will multiply 2 over 1 by 4 over 4. So 2 over 1, or 2 times 4 is 8. And 8 plus 25 is 33. And the denominator stays the same when we add fractions. Everybody okay with what we did there? Now the last steps are just going to be to get the y by itself. So I'll just subtract the 33 over 4 from both sides. And then how am I going to get rid of this, the over 2 on my y? Yeah, I'm going to multiply both sides by 2. Maybe I should use the dot. We have x's already going on in here. So I'm going to do that. When I multiply here, The times 2 and divides by 2 cancel out. When I multiply here, I'm going to FOIL once to the set of parentheses. I'm sorry, distribute once to the parenthesis and then once to the fraction. I can't multiply that 2 inside the parenthesis because I have that exponent going on. So I'm just going to write the 2 out front of the parenthesis. And then what do I get when I multiply 2 by 33 over 4? Should be able to do that in your head. If we just reduce the fraction before we multiply, we just end up with 33 over 2. You've never seen that shortcut for multiplication before? That's quite helpful in shortening up a fraction problem if you reduce before you multiply. Because the reducing gets harder the bigger the numbers get, right? Everybody agree with that? Yeah, so if we reduce before we multiply, the numbers never get too big. A little bit easier than reducing after you multiply, where the numbers are much bigger, it's harder to reduce. Let's do one more, okay? Will be the last example. After we finish this, we'll be done for today. Okay? What should I do first? Divide both sides by 3. Good. So 3x squared divided by 3 is just going to be x squared. 35 over 3x minus 7 over 3. So far, so good? Okay, now what? Good. I'll add 7 over 3 to both sides. Good. Now what? Add b over 2 squared to both sides. What is our b in this case? It's negative 35 over 3, right? So that's kind of gross looking. Now I want to say for the record, normally we wouldn't really like to have this fraction inside of a fraction thing going on here. I'm going to leave this for the time being, but it will not appear anywhere in my final answer. Just to be clear, it's not appropriate to have a final answer that has like what I'd call a complex fraction going on in it, where you have fractions inside of fractions. But that's okay for these intermediate steps here. Okay? Now what should I do? I'm going to factor that piece. going to look something like this. Everybody agree? What's going to go in this first spot? Just x. What's going to go in the second spot there? Not the divided by 2. Just the numerator. Because we want just the value for b. We don't want b over 2. Right? We just want the b. Now let's simplify things along the way here on our left-hand side. How do I simplify 35 over 3 over 2? Remember, a fraction is the same thing as a division problem, right? So that's the same thing as 35 over 3 divided by 2. Everybody's okay with that? How do I divide fractions? The way that I remember learning it in elementary school is dividing fractions as easy as pi. Flip the right and multiply. That rhyme has stuck with me after 30 plus years out after elementary school, and I still remember that. So I'll just change that from divided by 2 into multiplying by a half. And then to multiply fractions, we just multiply the tops and multiply the bottoms. Everyone okay with that? Now we should do the negative 35 over 6 squared. I need a 35 squared. I don't feel confident at doing at 8th hour on a Friday in my head, so I'm going to cheat and use the calculator. What? Completing the square problem? Absolutely. I mean, they're not so bad. Yeah. You have a calculator. It's not a big deal. It's not like I wouldn't let you use the calculator. Okay. So, let's continue kind of combining things on the left-hand side. To add 7/3 and 1,225 over 36, I need to have a common denominator. What would the denominator be? $36. To make that common denominator of 36, then I have to multiply 7 over 3 by 12 over 12. 7 times 12 is 84, and 84 plus 1,225 is 1,309. And then that denominator, when we add or subtract fractions, stays the same. Believe it or not, that fraction doesn't reduce either. So none of these fractions have reduced so far. Trust me, I've checked. And then the last step is going to be to get the y by itself. So the first thing I'll do is I'll subtract this 1,309 over 36 from both sides. And then what will I do next after that? Multiply both sides by 3. So I make sure I distribute on the right-hand side. But the 3 can't multiply inside of the parentheses because I have the exponent out there. So I'm just going to write the 3 out front. What do I get when I do 3 times 1,309 over 36? I get 1,309 over 12. Again, the trick that I used there was reducing before I multiplied. And there's my final answer. So I've posted 2 completing the square problems to PowerSchool, along with the answer, so you have something to check it with.